Well, I think we've covered the courtesy period to let people join. Want to thank you for being flexible with us and rolling with our reschedule to this week. As a full service consultancy, sometimes we're not fully in charge of our own schedule. So we thank you for joining us today. If you have to leave early, just remember we'll send out a video to this webinar in the next 24 hours. And I think with that, we can turn it over to Randy and get started.
Echo what Jason said, that thank you for the flexibility. Had some customer stuff come up last week. This webinar does not have a catchy title. We try to come up with catchy titles, but SQL Server Security 201 was the best that I could do. And what we're going to talk about here are some kind of internals around Windows Authentication in particular, service accounts, Kerberos, service principal names. So a lot of times when we think of SQL Server Security, you know, we think logins, users, permissions, you know, those are all important, but this is kind of a little bit more foundational than that. So just a little bit about SSG. If you're not familiar with us, if you've been coming to our webinars for a while, you've seen this slide a million times. SQL Solutions Group, I started this company in 2010. So I've been doing this for about 12 years now with SQL Solutions Group. Have been obviously in the industry doing SQL Server for much longer. And this is just a little bit about us and our offerings. And if you're attending our webinar for the first time, would love to have you reach out and chat with us and just get to know you a little bit. My name is Randy Knight. I am a Microsoft Certified Master in SQL Server. Started, as I said, with SQL Server in about 1997. So it's been a minute, starting with version 6.5. Prior to starting SQL Solutions Group, I did a lot of different things. Kind of my claim to fame, or the environment where I really worked with some pretty high volume transactional stuff, was at Match.com, who you've probably heard of. And again, started SSG 12 years ago, and we're a small kind of boutique consulting shop focused on the Microsoft data platform. Okay, so what we're going to cover today is a little bit about service accounts, which of course is the account that runs the SQL service, kind of as a foundational thing, some best practices. We're going to talk about Kerberos and how that works. And Kerberos is the security protocol that's kind of foundational for Active Directory. So if you're using Windows Authentication, as DBAs, this isn't something that we normally get very deep into, but it's important to understand because we do service principal name and Kerberos related issues are not uncommon. If you've been a DBA, if you've been an operational DBA for any period of time, you've probably run into this at one time or another. We're also in this presentation, we're going to talk about service principal names and group managed service accounts, which is the preferred method for running your SQL Server services. Talk about what those are and why that's a preferred method. Some troubleshooting, and that's the agenda. This is a very big topic with a lot of complexity for a 1-hour webinar. And also, typically, if you've been to my presentations before, I tend to have very few slides and just a lot of demos. In this particular case, it's the opposite, because it's just a topic that just seems to require some more slides and diagrams and things to understand. We will look at how this works and even potentially attempt to break it and fix it. We'll see. All right, service accounts, self-explanatory. These are the accounts that run your SQL Server services. The database engine, of course, is a service. SQL Server agent is a service. You're, for sure going to have those two. You'll have the SQL browser always, which typically is disabled. And then, if you have integration services, analysis services, reporting services, full text, those are all things that have accounts associated with them. The types of accounts that you can run your services with. Local computer accounts. If you're not in a domain, it's your developer edition SQL Server on your laptop or something, you can run it just as a local account on the local computer. Obviously not recommended for a production server. The next level is domain or Active Directory accounts, which is preferred, simply because we're taking the password, the database that contains the security information off of the SQL Server, right? So if the SQL Server is compromised, that doesn't necessarily mean they can get the password to the service account, so forth. Virtual accounts, when you install SQL Server by default, it will run the services under a virtual account. And we're going to talk about that because it has some interesting implications in terms of it doesn't look like a real account because it's not, it's a virtual account. So what's the security context of that virtual account? So we'll talk about that and actually look at what the service principal name looks like for that. And then finally, managed service accounts, which again are the preferred way to run your services, not just for SQL Server and anything that's a service that supports MSAs or group MSAs. I would highly recommend, taking the effort to implement that. Okay, virtual accounts. These are the default. If you do not change the accounts at install, and this is actually kind of nice. They started this, I don't even want to say what version, there's been a few versions of SQL Server, but they used to default to like local system or network service or some kind of the built-in local computer accounts that are a pretty insecure way to run things. So the way virtual accounts work is they delegate to the computer account. So one of the things that you may not be familiar with as a DBA is things in Active Directory. In addition to your authentication for users, right? So your user account that you log in with, a lot of environments, you have an admin account and a regular account. There may be domain admin accounts. You have service accounts, of course. Every computer, whether it's a server, workstation, laptop, domain controller, that is a member of Active Directory gets a computer object in Active Directory. And the way virtual accounts work, they look like this, right? So it'll be something like NT Service MS SQL Server. Or if it's a named instance, it'll have, MS SQL, $instance name, right? And you're probably familiar with that from just looking at services, right? What this does is it's a virtual account that uses that computer account. Those are the permissions that this service account will have, are those of the computer account. And that has some interesting ramifications that we'll talk about. Okay, managed service accounts. We'll talk about briefly here, and then a little bit later on when we get into the demo of actually doing this, we will implement managed service accounts. MSAs were introduced in Windows Server 2008 R2. And essentially what they provide, the number one reason why we like to use these is automatic password management, right? We know service accounts, best practices to secure a service account. We want it to follow the principle of least privilege, right? So we don't want it to have interactive login. We don't want it associated with an end user, right? We want it to have a strong password. And one of the things that we should do is rotate that password periodically. And if you've been around services and service accounts for very long, it's a rare environment that's actually happening. Most places that service account password is known to lots of people, might be using the same service account on all the servers, and it just doesn't get rotated. So what managed service accounts do is essentially you're almost outsourcing the password management to Active Directory. And we'll talk about how that works. but essentially that password will be 120 characters, and it's never known to a human. You can't go retrieve the password of that service account and use it. And so it's highly secure, and most importantly, it takes that whole rotating passwords, strong passwords, all of that out of our hands. It also simplifies service principal name management, which we'll talk about. And managed service account, or what they sometimes refer to as an SMSA, is associated with a single server. So we talked about that computer object that represents the SQL Server. That managed service account can be given permissions to be used by a single computer object. Okay. Group managed service accounts, and if you think about that limitation right there, and you think about the fact that in many cases, clusters, availability groups, by definition, SQL Server needs to be using the same service account on multiple computers. MSAs don't work. So in Server 2012, notice it's the very next version, so they realized the issue, and they introduced group managed service accounts. A group managed service account is nothing more than a service account that you can assign to a group or to multiple computers. And so this is the preferred mechanism for SQL Server in recent years. Extends the functionality to multiple servers and hosts. Some service account best practices. Separate accounts for each service. Separate accounts per instance or availability group. Again, availability group, all the replicas need to have the same service account. But normally, we would recommend a separate account per instance. Now, one of the things that comes up with that is permissions, right? That, we have this service account that we run all of our SQL servers under, and that way we can give it permissions to like the backup share or to different resources that we know all SQL servers are going to need. And the way to manage that, the preferred way to manage that would be through a group, right? So separate service account for each instance, put them all in a global security group, assign that global security group the permissions. Always use a domain account, even if you're not using a managed service account, at least it should be a domain account in Active Directory. It should not have an interactive login. It should not be associated with a user. One of the things I think from a security standpoint, if you're not a security person, to think about when you think about things like admin accounts, service accounts, things like that, is this. Any account that is associated with an email address is inherently insecure, right? So if you're in an environment where you have your normal login that's associated with your email, that's associated with all your normal access to user level things, and then you have an admin account, which is a separate account in Active Directory that you use for access to production servers. That's why, right? And if you're not doing that, you probably should. Strong password with regular changes. Okay, couple of key points here. Your service account for SQL Server does not need to be and should not be a local admin, right? We're all familiar with the principle of least privilege. Unfortunately, what happens in many environments is the principle of most privilege gets followed because it's easy. If I make my service accounts local admins, I don't have to worry about permissions. I don't have to worry about this. I don't have to worry about that. So your service account does not and should not be a local admin. Number one, if you take nothing else away about service accounts from this webinar, take this. When you change your service account, whether it is just rotating the password or actually using a different account, it is critically important to use SQL Server Configuration Manager or a tool that uses SQL management objects. So there's like DBA tools, PowerShell commands you can use for this and so forth, because the SQL Server Configuration Manager manages the permissions that the service account needs. So if you change your service account it's not a local admin, and you use like the services control panel to do that, it's not going to have the permissions that it needs to run SQL Server. When you change it with SQL Server Configuration Manager, it takes care of that for you. And that's important. The most important though is there's a key called the service master key that exists on every SQL server. If it doesn't exist and it's needed, it will automatically be created. And that is the root of the encryption hierarchy for SQL Server. So if you have database master keys, those are dependent upon or subordinate to the service master key. If you're using things like, transparent data encryption, always encrypted, all of those keys are going to be based upon that service master key. The service master key uses the password of the service account as its seed to generate that key. So when you change the password of the service account, you need to recreate the service master key. SQL Server Configuration Manager does that for you. So always use SCCM or SQL Server Configuration Manager to change the service account. Okay, let's talk about the Kerberos protocol, and let me just really quickly check for any Q&A. I don't see any thus far. Feel free to post anything in the Q&A, and we're happy to cover them. So let's talk about Kerberos. And so this gets a little bit into theory in terms of how this works. Kerberos was developed at MIT back in like the 80s, 90s. There's a public RFC associated with it. This is not a Microsoft thing by any stretch. It is ticket based, and we're going to look at the ticket flow and talk about exactly what that means. But essentially, a third-party trusted authority creates a ticket. And so in some cases, some resources that you look at will consider services as untrusted authorities. So whether it's a web server, a file share, a SQL server, whatever it is you're trying to authenticate and get access to, we don't trust it enough to give it the password. So what we're going to do is we're going to authenticate with the password elsewhere, or however we do authentication. It could be MFA, it could be passwordless, smart card, whatever. And we're going to create this ticket, which we pass around to these services to say, hey, I'm verifying that this identity, user, service, whatever, client has permissions to access this resource, right? I've heard this described kind of as like, you go to the nightclub, right? And, you get carded at the door and they give you your hand stamp, and then you go to the bar to get a drink and you don't have to get carded because someone else has already validated that you are authorized to be in that club, right? Based upon that hand stamp that you have. Maybe it's a reception where you get tickets for 3 free drinks, right? Well, you take those to the bar, you give them your ticket, they give you a drink, right? It's already paid for. All right. In Windows 2000 Active Directory, which is really when Active Directory as we know it came to be, Kerberos was implemented as the preferred authentication mechanism. There is another authentication mechanism called NT LAN Manager that is very, very legacy that it will fall back to if it cannot use Kerberos, but Kerberos is preferred. There is a way that it actually can be forced in Active Directory that we say we have to use Kerberos. And I had to put this on here because this is the part that hopefully will raise some eyebrows for DBAs. It's implemented via the Security Service Provider Interface, or SSPI. If you've been a DBA for any period of time, at some point you've seen that generic error could not generate SSPI context, right? And what the heck does that mean? How do I troubleshoot that, right? That error is a Security Service Provider Interface error. It's directly Kerberos related, and it's almost always service principal name related, and we'll be looking at that. Okay, some definitions. You have a client. This is the user or application, right? Application is probably more accurate because if I go and I'm using SQL Server Management Studio and I want to connect to SQL Server, really it's SSMS that is needing access to the SQL Server, right? Server or service is almost a better term to use here, is the service the client needs access to, the SQL Server in this case. Then you have this term key distribution center, and I'm including these definitions because when you look at Kerberos resources, you know, if you Google it, things like that, you're going to see these things like KDC and AS and TGS and TGT and what the heck are all those things. So that's what we have going on there. The key distribution center has two roles. It authenticates clients using whatever authentication mechanism you have, typically username and password, and distributes tickets. Consists of, in the Kerberos protocol or in the Kerberos specification, it consists of authentication service and a ticket granting service. In Active Directory, those are combined into one thing, and the KDC is the domain controller, right? So if you're using Active Directory, every domain controller is a key distribution center. All right, there is a ticket granting ticket, which is the initial ticket that you will get when you authenticate, right? So you go to the authentication service, and we have a diagram on this in a minute, and it gives you a ticket granting ticket, which you can then use to generate service tickets, right? Or request service tickets. So you can kind of think of this if you're familiar with, you know, public key infrastructure and how keys work. You have multiple levels of the key hierarchy, right? You have a root certificate authority, you have intermediate certificate authorities, and you have ones below that. And those are all considered subordinate authorities. This is kind of the same way. The ticket granting ticket is the root that allows you to generate other keys or other tickets. And then the service ticket, of course, grants access to the service. Okay, so let's take a look at how this works. We have a user over here on an application, and we have a domain controller, and we have a resource. The resource in our case would be a SQL Server service, right? So the first thing that happens when this user logs into Active Directory, logs into their workstation, they're going to contact the domain controller and they're going to request a ticket granting ticket. The domain controller authenticates them, sends that back. Now this identity has that TGT and a session key that's associated with that login session that they carry around with them for as long as they're logged in, right? And when they want to access a resource, whether that's a file share, you know, Exchange email, SQL Server, you know, RDP to a server, whatever it is that you're doing in Active Directory, you're going to send that TGT and request a ticket to that service. And now the ticket granting service is going to say, okay, I know this user is authorized, is authenticated, but are they authorized to use the resource they're asking for? Yes, they are. It then sends that ticket. Now the identity can go directly to the service and say, hey, I have this ticket that says I'm allowed to access you, and it says, awesome, go for it, right? That's how Kerberos works. Notice that this resource server here never got anything associated with authentication, right? No username, no password, none of that, just the ticket, right? So, and that's one of the reasons that Windows Authentication is so much better than SQL Server Authentication. One of the many reasons is because none of that is happening between the client and the server, just the ticket. Okay, that brings us to SPNs, or service principal names. A service principal name, you can think of this service identifier, or in our DBA world, as the primary key that uniquely identifies a service or a resource. Going back here, this guy, right? Every resource that you're going to authenticate to with a ticket with Kerberos has to have a service principal name associated with it. It maps to the SQL Server service account on the SQL Server. It is required for Kerberos. If you do not have a service principal name registered, you're not using Kerberos. You'll be using NT LAN Manager. Has to be registered in Active Directory. So how does that get registered? In most cases, at startup, SQL Server will register the service principal name, and we're going to look and we're going to see in the SQL Server log exactly where we see that. It will actually deregister it when it stops, and it just does that. But to do that, the service account has to have permissions to register an SPN in Active Directory. Virtual accounts and managed service accounts already have the permissions that they need to create SPNs. So that's one of the benefits of those. But if you switch to a domain account that does not have that permission in Active Directory, which we'll look at what that permission is, it will not be able to register the SPN, and you will have to register the SPN manually, which you can do using a utility called setSPN. Microsoft has a downloadable utility called the Kerberos Configuration Manager. It's a big download and it doesn't work that well in my opinion, so I don't recommend it, but it is an option. And then of course, you know, if you've been to any of my presentations, you know that I'm a big fan of DBA Tools, Community PowerShell module. They actually have some really good commands around SPNs that we'll be looking at today in the demos. Okay, SQL Server Tools. SQL Server Configuration Manager we talked about. Always use this to change your service accounts. If you're in a cluster, change it on the active node, of course. It will set the correct permissions for the new account, and it will deal with the service master key. sys.dm exec connection. So one of the things that comes up is, oh look, I have a typo there. That should be an underscore. That comes up is, how can I tell if Kerberos is working in my environment, right? And the answer is there is a column in exec connections called auth scheme that will tell you, is this, how is this authentication happening? All right, so let's switch to a demo here and take a look at what we have. What I have here is an isolated lab environment. So I have a single domain controller called labdc with Active Directory, and I have a SQL Server lab-sec201, which is a member server of that domain, with a completely default SQL Server installation, right? This is not best practices. Everything's on the C drive. What we care about here are service accounts. And so as you can see, I have the SQL Server service running under the virtual account, MS SQL Server. I do have the agent running, so I did change that. That's normally manual and stopped. The other thing that I've done in this environment to make it easy to see what's going on, this is Developer Edition. So by default, TCP/IP would be disabled, name pipes would be disabled, and shared memory would be enabled. Shared memory is used when you're on the same server, right? So if I fire up SQL Server Management Studio on this server, connect to this server, it would try to use shared memory if it was enabled. And so I just have that disabled to make it easier to see in the exec connections where all these connections are coming from. Okay, so let's take a look at a couple things. I'm going to go over here to Visual Studio Code. I have the DBA Tools PowerShell module installed. I'm giving it a variable that's my server name. And I also want to be aware of IP addresses so that when I look at the exec connections, I know who's what. So I'm on the domain controller whose IP address is 192.168.10.175. And if I look at the actual SQL server and look at its IP address, it's .170. So the server is 170, domain controller is 175. All right, let's look at our service accounts. This is the same thing that we were seeing in SQL Server Configuration Manager. It's just a DBA Tools command. And again, I can see again those two services that are running as the virtual accounts. The next thing I'm going to do here, and I could do this in Management Studio as well, is look at the SQL Server log. And I'm just going to say, hey, give me anything in the log with SPN in the text. And I'm going to sort it descending. And let's take a look at what we have. So what we see, there's quite a few of them here. It's sorted descending. So the most recent, 10:30 this morning. And if you take a look at this, the SQL Server is attempting to register a service principal name. And we actually got an error this time that it could not register, which is interesting because I wonder if it's because the domain controller was starting at the same time as the SQL Server. So we may not have SPNs. Okay, so the SPNs do exist, right? So this command here, if we look at this, get DBA SPN or test DBA SPN or set SPN, the command line utility, that's Microsoft, these are DBA tools, will actually give you the service principal names that are registered for this server. And if you look at the SPN, if we go up here, there's a couple of things here. The account name is going to be the Active Directory account that service is associated with for authentication, or the service account. Notice that the name, we have the domain, but the account is not that MS SQL Server virtual account. It's lab-sec201 $. That's the computer account in Active Directory, right? And we're going to look at that actually in Active Directory users and computers in a little bit here. The service principal name is going to always be MS SQL Service / the fully qualified domain name of the SQL Server. And you actually have two of them. You have one with a port associated with it, and you have one without a port. The one with the port is for TCP/IP, the other one is for named pipes. So you always need those two service principal names registered in order for Kerberos to work. Okay. Note that you can also use set SPN-L to list SPNs. So this actually gives me all the SPNs associated with this server, right? So not just, so there's the two SQL ones, but we also have terminal services. We've got some, WinRM service principal names. Anything in Active Directory that's using Kerberos has to have a service principal name associated with it. Okay. All right. Let's go establish a connection. So we're going to go to the domain controller. So this is a remote connection, right? So I'm going to go to SSMS and I'm going to connect to my server. And I'm just going to query sys.dm exec connections. And we can see all these connections. And we can see in the auth scheme column, there's some that say they're NTLM, there's some that say Kerberos, right? So what does that tell us? One, it tells us that Kerberos is working in our environment, right? The NTLM are local. So one of the things you have here is you'll have the local address and the client address. If those two are the same, those are local connections from the SQL Server machine to itself, which will always be NTLM. Kerberos are the connections from the domain controller, such as this one that I'm looking at right now. So I'm using session ID 69, which is this guy right here, and we can see that that is a Kerberos authenticated connection. Okay. So that's Kerberos working the way that it's supposed to, right? Let's look at one more thing. I'm going to go to Active Directory. And I know this is, getting outside of the realm of where DBAs spend a lot of our time, but I think it's important to understand what's going on here. So we have a computer object, labsec201, which again is referenced with that $sign. And I also need to make sure that I have advanced features enabled. And now I'm going to go to computers, security, advanced. And what we're going to see here is that these are all the accounts in Active Directory, whether they're computers or users, and what permissions they have to this computer account, right? And one of those permissions is validated right to service principal name. This is why the computer object can create its own SPN. Okay, so that's the permission that any service account is going to need to have within Active Directory in order for this to work. All right, back to the slides. Talk about MSAs, and let me check questions.
Yeah, there's a few there now. Really.
There's a few here. Try to use gMSA as identity of a credential so it can be used as a proxy to run SSIS packages. Let me hold that one. So double hop and constrained delegation. I would love to have included that in this session. I'm going to talk about it. There just wasn't enough time in an hour, but that is one of the biggest issues. So we'll definitely talk about that. Do you need to be a domain admin to run Kerberos Configuration Manager? No, but you need to have permissions to set SPNs, right? So a domain admin can do that. That same permission that we were looking at are the permissions that it's going to need to have. Okay, and then we'll come back to the constrained delegation and the proxy. And off the top of my head, I can't say that I've tried a gMSA as a proxy, so that would be interesting to, I may play with that and answer that question like in a blog article or something. Okay, so we talked about managed service accounts introduced in 2008 R2 of Windows, SQL Server 2012. Only one server can use it. Group MSAs extend the functionality of multiple servers. Windows 2012, SQL Server 2014, right? So SQL Server 2012 is end of life this year, or end of extended support. So hopefully everyone is on, 2014 or higher, but that is required for gMSAs. Active Directory managed passwords, never human we talked about all that, right? If you are familiar with LAPS, or the local admin password solution that is sometimes used for workstations, so that you don't have a local admin password that is known to lots of people, Microsoft has the LAPS, or local admin password solution, that does the same type of thing. The difference is that MSAs are for servers and services. Okay, so what are the components for a group managed service account? There's a key distribution service, it's part of Active Directory. Every domain controller has it. It creates and distributes a key associated with the gMSA, and it rotates that key automatically. The domain controller uses that key to compute the password. Okay, so this is all just public key based. The host or service retrieves the password from the domain controller. When you set up your gMSA, when you set up SQL Server to use the gMSA, you don't give it a password. You tell it to use this gMSA, and all of that happens behind the scenes. So you never know the password of this account. Requisites. Your domain has to have Windows, at least one Windows 2012 or higher domain controller. This is not the functional level of the domain, right? So it isn't the type of thing where you have an old domain functional level, so you can't do this. What happens is when you have a Windows 2012 domain controller, it extends the Active Directory schema for the entire Active Directory, and there are some things that are needed for that. You have to be using Kerberos. No Kerberos, no managed service accounts. you have to have a root key that has been created for your key distribution service. This is a very simple PowerShell command to create this root key. You can't use gMSAs if you don't have the root key. On SQL Server, Windows 2012, SQL Server 2014, and your implementation steps will be confirm or add the KDS root key. There are some PowerShell commands that we're going to use to see how that works. Add KDS root key. One of the things to know is that when you create your root key, and that has to be done by a domain admin or maybe even an enterprise admin, but that'll be your Active Directory people. It can take up to 10 hours to become usable, to replicate to all domain controllers. And in fact, in preparing this demo, I found that even with just a single domain controller, if you create the KDS root key, you can't use it for 10 hours. And I have a little bit of a hack so that we can do this within the context of the demo, but just be aware of that. So if you're going to implement gMSAs, the very first prerequisite thing to do is to get your Active Directory team to create the KDS root key well ahead of time. You can then create a group which will contain servers that are going to use the gMSA. You don't have to do this. You can assign those computers directly to the gMSA. That's what we're going to do in the demo to make it simpler, but the preferred method would be to create a global security group. And then you create the service account. This is a specific type of account. You use a Active Directory or a PowerShell command to create it. And you're going to, when you create that MSA, you're going to authorize the group or the computer to retrieve the password. Finally, you're going to change the service account using SQL Server Configuration Manager. Somehow I put System Center Configuration Manager there, so that's definitely a typo that we'll fix before we distribute the slides. And you add a $sign to the end of the account name. That's how SQL Server knows that this is a MSA and you don't have to provide a password. Okay. All right, so let's do this. Go back over here to our domain controller, and we have our domain. So I have a few variables here. I have the fully qualified domain name, lab.sqlsolutionsgroup.com. I have the name of the computer account, which again, we have to have a $sign at the end to tell AD that it's a computer account. And I have what do I want to call my gMSA. One of the requirements of a gMSA that's kind of a hassle is that the maximum length of the account name is 15 characters, which can be limiting, right? If your naming convention is longer than that. So it is what it is. All right, so if we look at our domain and we run get KDS root key, nothing comes back. We don't have a KDS root key, so we need to add that. What I'm doing here, normally we would say add KDS root key effective immediately, right? And so it would start now and we'd have to wait 10 hours to use it. So what I'm doing is I'm actually giving it an effective time of 10 hours ago, right? Because I only have one domain controller. This is safe to do. This is a lab environment. You would not ever want to do this in your production domain. So I'm going to go ahead and add that. Let's see. I think this doesn't like PowerShell core. So, and switch to regular PowerShell. And run that command. We can see that I got a GUID back from it. So now if we say get KDS root key, didn't like it there either. So we're just going to do this over in this guy. So if we say get KDS root key, we can see that I have this key. The effective time was, again, 10 hours ago, creation time, format, domain controller, server configuration. We're good to go with our KDS root key. There's also this command, test KDS root key, which is going to return true or false. So if I take that right there and run it here, it just returns a true, right? Once I have the root key, I can create the service account. So I'm using variables here. So it's new AD service account, the name of the account. The principal's allowed to retrieve the managed password. I'm just using the computer account here. Again, this could be a group that contains one or more computer accounts. It's enabled. I want it to rotate the password every 30 days. I can have that be as whatever value I want. And finally, I have to give it the fully qualified domain name of the host, which is the account name.domain, right? I'm going to go ahead and run that command. And I need to run all of this over there, don't I? There, go there. Okay, so now I created my service account. If I go to Active Directory users and computers, there is actually a folder that I can see, and I can see that my managed service account has been created, right? All right, now I'm going to go over to my SQL Server, and I'm going to go to my services, and I'm going to go to the SQL Server service, and I'm going to change the account. And I'm going to change it to lab gMSA all that full name. gMSA lab sec 201. I can't remember if I had SQL on that. gMSA lab sec 201 $. By including the $, I'm telling SCCM that this is a managed service account, so I don't have to provide a password. I'm going to say OK. It's going to restart the service. Always is going to do that when I change a service account. Takes a minute because it has to use the KDS to go get the password and do everything that it needs to do. And we now see that my SQL Server service is running as the gMSA. That's how easy it is to implement gMSAs. And once you've done that, you never have to touch that SQL Server account ever again. It's pretty slick. I go back over here and we go back to our logs and so forth. We can say, you know, test DBA SPN, and let's see what we have. How about that? We have a missing service principal name. So the DBA tools command automatically checks the SPNs based upon the service account. We changed the service account. The service account did not have permissions to create the SPN, so we have a missing SPN. So what's the impact of that? Well, if I go back over here to my SQL Server and reconnect, target principal name is incorrect, cannot generate SSPI context. This is that error that you'll see. Now, I should be able to, in some cases, I'll be able to reconnect and it will default to NTLM. Certainly if I go over to the server itself and look at it, but I'm, you know, this is kind of broken, right? So how do we fix that? We're going to go over here and we're going to go to this command. Now I can use set SPN or Kerberos Configuration Manager for this as well. But what I'm going to do, we saw this test DBA SPN that I just give it the computer name and it tells me if the SPNs are set. But then what I'm doing is I'm piping that to where object is set equals false, right? So that's this is set property. And then I'm passing that to set DBA SPN. I'm a domain admin in this lab domain, so I have the permissions to create SPNs. Whatever security context you run this under is going to have those permissions. But when I run that, failed to add SPN, a constraint violation. How about that? So this is the kind of stuff that you run into. And I actually had a couple people tell me I was crazy to demo SPNs because this is the kinds of things that you run into. So what we have here is we have some duplicate SPNs in our Active Directory that we can try this. Sometimes this gets really hairy trying to clean this up. I think that is probably not going to work. Yeah, the constraint violation. So this is where we would have to really dig with set SPN-X. I actually, believe it or not, we have a consultant here at SQL Solutions Group who's not a DBA consultant. He's part-time for us, but is a master in identity. Actually helped write the Microsoft Certified Master for, I think they called it directory at that time. Now it's called identity. That, you know, he's the guy that whenever I run into these hairy issues in customers' production domains that we bring in. So that's service principal names, group managed service accounts. And, you know, if we had time, we could go back and really dig in and fix this. But there's a couple things that we want to talk about, and there's 8 minutes left here. So key point, I hope that's taken away there, regardless of the SPN troubleshooting, which we'll get to, is that group managed service accounts are really easy to implement and are, you know, very powerful. Okay, troubleshooting missing or incorrect SPNs. That's exactly what we have going on in our domain. The set SPN utility, DBA tools, the Kerberos configuration manager, all can be used. When you have missing SPNs, in many cases, you'll have fallen back to NTLM authentication without knowing. And so there's that. And this brings up the question that was brought up about the NTLM authentication and 2-hop, right? So Kerberos 2-hop, and again, I would love to have been able to demo this if we had a little bit more time. Maybe I'll follow up with a blog article. Is when you are authenticating to a service, which then is going to impersonate you to authenticate to another service. And the classic example here is a web server using Windows Authentication for the services, right? Where I go in my browser, it authenticates me to this application server using my Active Directory credentials. It does that using a ticket, right? And then it's going to say, hey, we're using this to go connect to the database based upon this user's permissions. And it passes that ticket to the database service. That's the second hop. And there's some specific delegation infrastructure that you have to have in place in Active Directory for that to work. That's the classic example that you'll read about. The one that matters to DBAs, or that I see the biggest issue with, relate to linked servers, right? And I'm going to take just a minute to illustrate this. I don't have any linked servers here, but I'm just going to go and let's see, except for that I have a broken connection. So let's go to that. Did not work either. What did I use for that? Okay, so I'm not going to have the opportunity to show that. But when you set up a linked server, you can tell it to use the login's current security context, which is preferred. But if you're using Windows Authentication, that is going on there. That by default is going to be 2-hop, right? SSMS or whatever your application is connects to the SQL server that has the link server on it. The link server then in turn connects to the remote server using that Kerberos authentication. And what happens in many environments is I can't get Windows Authentication to work. And so we use remote login mapping with standard authentication, which if we're actually mapping logins, that's not that bad. But the thing that I see in almost probably 90% of link servers out there is authenticate using this security context for everybody. Standard account, and in many cases, it's a privileged account on the remote server, right? So it's a sysadmin or a database owner. So now, regardless of the permissions that the user has that's using the link server, that's a huge security hole on the remote server. And so having 2-hop work, and maybe I'll do a follow-up video or something, because that is a really important topic. When I came up with this webinar, this was all important, but it's a big topic. So that's briefly 2-hop. Okay, let's go to the Q&A. We've got a few minutes here, and I've got time. I can stick around. The proxy question, I actually want to try that because I've not tried using a gMSA as a proxy. So that's interesting. So I'll follow up on that one. I answered do you need to be a domain admin to run Kerberos Configuration Manager? The last question there was, what happens with the permissions to the SQL data directories when you do this, when you change the service account? That's why we need to use SQL Server Configuration Manager to change it, because it will manage that for us. If we use services or some other way to do it, then we would need to go manually fix that. And we've seen that issue before in customer environments. And there is Microsoft has a really good article in Microsoft Docs that, hey, these are all the permissions the service account should have. But it's pretty long, it's pretty ugly, right? So always better to set it up, with Configuration Manager, let it manage the permissions, and go from there. So, all right, Jason, I think that's all the questions. And let's just, make sure we make notes of those things, the proxy and the 2-hop, because I would like to do some follow up on that, either via video, another webinar, probably not another full webinar, but video or blog type of thing, because it's a big topic. So thank you for taking the time to attend. And if there are other questions, things, I'm happy to stick around for a bit here. I've got a few minutes. Also wanted to point out that next month our webinar is going to be about DevOps, and Steve Jones from Redgate and SQL Server Central. Most people who've been around the community all know Steve. Is going to join us, and Scott Klein, one of our senior consultants, has actually been doing a DevOps project with a customer using the Redgate DevOps tools, and so they're going to just take some time and talk about that. So encourage you to look for those emails, and we'll just keep it rolling. Thanks.
Thanks, Randy. I just shared a link to that upcoming webinar in the chat, so that's convenient for you. When we send video for today's webinar on Thursday, we'll include details about that upcoming webinar as well. Doesn't look like any new questions, but we'll hang on here for another minute or two and give you a chance to comment if you have anything.
All right.
Everybody's thinking about what you shared, Randy.
There we go. Okay. Well, we will drop off then and talk to you next time. Obviously, Twitter, email. Happy to answer any questions that maybe you think of after the fact.
Great.
All right.